Hello and welcome to Mr. Tompkins EdTech and my series of walkthroughs for the AQA GCSE Mathematics past papers. This particular video is June 2018, paper 3, Foundation Tier. Now, with the new specification being new, grade 9 to 1 past papers are like gold dust, and you should not be watching this video unless you've already attempted the paper yourself under test-like conditions. If you haven't, stop the video now and go and do it first. I'm serious, go. Still watching? That's great. Why not subscribe to my channel so you can easily find it again the next time you want some help with your maths. I have plenty of A-level content too, so make sure you come back and check that out if you're carrying on with your maths next year. Please hit the like button if you found the walkthrough helpful. This really helps out my channel and it makes it much easier for others to wade through all the YouTube dross and find the good stuff. Also, before attempting the actual past papers, make sure you've gone through all the practice sets first. AQA produced 4 sets of practice papers to help students prepare for the new GCSE exams, and I would advise you to work through these before moving on to the actual past papers. Have a look at this video series which gives full walkthroughs for AQA practice sets 1 to 4. If you don't happen to have a copy yourself, you'll find a download link to the practice paper in the description below each video. Finally, feel free to ask questions below. It would be helpful if you include a question number and be as specific as possible. I really appreciate your comments and feedback, and I try to respond to these as quickly as I can, especially around exam times. Okay, let's get into it. Welcome along to another AQA past paper walkthrough. This one is June 2018 paper 3, and this is the foundation tier paper. So, question 1. Circle the value of the digit 7 in 9.17. Okay, so this digit in here is in the hundredths column, isn't it? You've got units, tenths, and then hundredths. So, it literally means 7 100ths. It's that one there on the end. Question 2. Solve 3x equals 2. Okay, so dividing both sides by 3, that will cancel with that, leaving you with just x on the left-hand side, and you'll get x is equal to 2 over 3. So that's my solution there. Question 3. Which of these shapes has no lines of symmetry? Circle the correct letter. Okay, so let's just try and rule some of these out. I think that triangle there has got a line of symmetry running through the middle of it, hasn't it? Okay. Line of symmetry is like a mirror line or a fold line where one half will fold on top of the other. So this shape has got one there. So that's got symmetry, and this one has got symmetry here, isn't it? So the only one that doesn't have symmetry is that one there, number A. It's the parallelogram. Question 4. Circle the shortest length. So we've got a mixture of units here. We've got centimetres, kilometres, metres and millimetres. So to compare them, it's probably a good idea to put them all into the same sort of unit. I think I'm going to go for metres. That's kind of in the middle of all these, isn't it? So 1200 centimeters. Now there are 100 centimeters in 1 meter. So dividing 1200 by 100, or in other words, crossing out 2 zeros, 1200 centimeters is going to be the same thing as 12 meters. 0.13 kilometers. There are 1,000 meters in a kilometer, in 1 kilometer. So multiplying 0.13 by 1,000. If you find that tricky to do in your head, you can always use a calculator, but I make that 130 meters. Well, that one's already in meters, that one's fine, 110 meters. And then finally, 140,000 millimeters. Now there are 1,000 millimeters in a meter. So here we need to divide by 1,000 or scratch 3 zeros. 1, 2, 3. So 1, 2, 3. So that in meters is going to be 140 meters. So which is the shortest? It's this one here by a country mile, isn't it? Question 5a. Shade 2/5 of this grid. Okay. So how many rows have we got? We've got 2 rows, and we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns. So if we divide it up into fifths by kind of subdividing it this way, so every 2 columns we can divide it up, we'll make fifths. Oops. Then I can then shade 2 of those 5/5 then, aren't I? So I can shade that one there. That's 1/5, and that's my 2/5. Another way of thinking about it is finding you've got 10 by 2, which is 20 squares altogether. Multiplying that by 2/5. So you can either do that on your calculator or take 20, divide it by 5, get 4, times it by 2, get 8. So you can see that that's 8 little squares you'd need to shade 2/5. Okay, now this next one, 5b, shade 10% of this grid. Now I've got 5 squares in this direction and 4 in this direction, and 5 times 4 is 20. So 10% of 20 is 2, isn't it? So if I can shade 2 of the squares, I'll be shading 10% of it. So if I shade those 2 there, for instance, that would be 10%. Question 6. Saj wants to go to all 19 home games at a football club. For each game, a ticket costs £28. A season ticket costs £379 and gives entry to all 19 home games. In total, how much does Saj save by buying a season ticket? Okay, so what we're going to have to do here is we're going to have to work out what the cost is of going to 19 home games at £28 each, and then compare that to the price of a season ticket. Okay, so let's do that then. So what is 19 lots of £28 then? Let's just tap that into the calculator and find out. 19 times 28 is £532. Okay, so if you just bought 19 tickets, it would cost him £532, but obviously the season ticket is cheaper. That is £379. So if we're going to subtract that from our total, what we're going to get now then? So 532 subtract 379. That has got a difference of 153. So in total, how much does Saj save by buying a season ticket? He saves £153. 153. Question 7. Link the algebra to the correct description. 1 has been done for you. We can see that this first one, p equals 3x plus 4y, is linked to formula. Now the next one down says 3x plus 6 is, can you see that symbol there? It's what we call an identity. It's a bit like a super equals. It's true for all values of x. So it doesn't matter what the value of x is. 3x plus 6 will always be equal to 3 lots of x plus 2, which is why it's an identity and not just an equation. So we're going to be linking that one with identity. Okay, 3x plus 2 equals 14. That's just simply an equation, isn't it? So it's just got one unknown in it, which makes it an equation. And then finally, I've got 2 more things down here. I've got 3x plus 2. That's what we call an expression. There's no equal signs in an expression. And then finally, I've got 3x plus 2 is less than 14. And that then is my inequality. Okay, so that's that done. Question 8. Jim has 6 banknotes. The value of each note is £5 or £10 or £20. He can make £20 with 3 notes. He can make £55 with 4 notes. He cannot make £25 with 3 notes. He cannot make £25 with 4 notes. List the 6 notes. Okay, so he can make £20 with 3 notes. So if it was, how can you make £20 with 3 notes? Well, you can make it if you've got a £5, a £5, and a £10. Are there any other ways of doing it? No, I don't think so. I just think that's the only way you can make £20, isn't it? With 2 £5 and a £10, that's the only way of doing it with 3 notes. Okay, let's have a look at the next one. He can make £55 with 4 notes. Okay, how many different ways are there of doing that? So let's think about this. If I had 2 £20 notes, then I'd have to make £15 with 2 notes, which I can do. That works. So I can use £5, a £10, a £20, and a £20. Is there any other way of doing it with 4 notes? I don't think there is. I think that's the only way of doing it. So that combination must be possible. So looking at these two together, then if I can make £20 with a £5, £5, and £10, I must have at least 2 £5 notes. And if I can make £55 with 4 notes, which is a £5, £10, £20, £20, I must have at least 2 £20 notes. Plus, I must have at least 1 £10 note. So I reckon I know 5 out of my 6 notes now. I'm definitely going to have a £5, a £5, a £10, a £20, and a £20. I just don't know what other one I can have. Let's have a look at these last 2 expressions. He cannot make £25 with 3 notes. Cannot make it. So given that I've got 2 5s, a 10, and a 2 20s plus 1 other note. Okay, so I've got a 5, a 10, a 20, a 20, and a mystery note. Okay, now I can't make £25 with my notes, with 3 of my notes. So if I had £10, £5, that means I can't have another £10 then, doesn't it? Because if I did have another £10, then I could have a £10, a £10, and a £5, making £25. So my last note there, my mystery note, is not a 10, which means it's either a 5 or a 20 then, isn't it? So he cannot make £25 with 4 notes. Cannot make £25 with 4 notes. Okay, so if I used these 3, 5, 5, and 10, that adds up to 20. Then if I had another £5, I could make £25 with 4 notes. But if I cannot, then it can't be that one either, which means my last remaining note must be a 20. In which case then I've got 2 5s, 1 10, and 3 20s. That must be the only way I can do it. So 5, 5, 10, 20, 20, 20 is the only way I can meet all of those conditions. Question 9. A music app has a shuffle play function. This means that songs are played in a random order without repeat. Ruth plays 10 songs on shuffle play. One of them is her favourite song. Write down the probability that her favourite song plays first. Okay, so probability is defined to be successful outcomes divided by total outcomes, isn't it? Now, if I'm picking a song at random from 10 songs, then my total outcomes is going to be 10, isn't it? Now, she's only got one favourite song, So for this to be successful, we need to pick her one favourite song out of the 10 songs. So the probability that it picks her favourite song first, is going to be 1 out of 10. Okay, 9b. Ted puts songs A, B and C on shuffle play. List all the possible orders of song A, B and C. The 1 has been done for you. So we could start with A and then we could have B and then C. I like to try and keep as many things the same as possible. So let's leave the A there. Then I could have a different combination if I had C then followed by B. So ABC is one way and ACB is another. Now what happens if we start with B? I could have B then followed by A and then followed by C. Or I could have B followed by C followed by A. They're all the outcomes starting with B. So then let's try C. If I start with C, then I could have A next and then B. Or if I start with C, I could have B and then A. So altogether, I've got 1, 2, 3, 4, 5, 6 different orders I could play those 3 songs in. Question 10. Here is a scale drawing. I've got a Ferris wheel, which I'm told is 130 meters tall, and then next to it is a very tall building. And we're told that the height of the Ferris wheel has a height of 130. Well, we knew that already. Work out the height of the building. Okay, so basically what we want to do here is see how many Ferris wheels fit into the building. Okay, now the way I'm going to do that is I am going to look on my ruler at what size this 130 is. Now this is a bit of a virtual ruler, not quite the same as yours. I wonder how it would look on a real ruler. Now according to the mark scheme, if you measured this with a ruler, you should find that it is 2 centimeters tall from there to there, roughly. And then if you measure the very tall building, you should find that from there down to there measures 10 centimeters. Now my ruler, you'll notice, doesn't have any marks on it, so I can't really show you that, but that's what the mark scheme tells me. So you should, if you measure it correctly and your paper's been reproduced properly, have 2 centimeters and 10 centimeters in here. In other words, the building is 5 times taller than the Ferris wheel, isn't it? Because 10 divided by 2. So the scale factor of these 2 buildings is 10 divided by 2, which is 5. Okay, so the building is 5 times bigger than the Ferris wheel. Now we're told that the Ferris wheel is 130, so then the height of the building is going to be the height of the Ferris wheel, which is 130 meters, times a scale factor of 5. So tapping that into my calculator, I should get 130 times 5, 650 meters tall. Oops. 650 meters. Question 11. Joe has a full cup of coffee. She drinks some of it and she says half of the coffee is still in the cup because 5 centimeters is half of 10 centimeters. Is she correct? Now, I am definitely what you would consider to be a cup half full kind of guy, a bit of an optimist. But here, in this case, even though 10 is half of 5, look, the amount of coffee that's in this section here above that 5 centimeter line is going to be much more than the coffee underneath, because it's tapering down, isn't it? So, no, she's not right. So, tick a box. No. So, give me a reason then. So, the width of the cup is smaller at the bottom. Question 12. Our takeaway sells 10-inch pizzas and 12-inch pizzas. Here is some information about the numbers sold in 2 weeks. And we can see in week 1 we've been given a table of values. And we can see that 10-inch pizzas, 512 were sold, and 12-inch pizzas, 231, giving us a total of 743. Underneath we have what's called a frequency tree, which is a little bit harder to read, but I'll explain that in a minute, I suppose. So then 12A says, in each week a proportion of pizzas sold were 10-inch. In which week was this proportion greater? Show working to support your answer. Okay, so basically we want to know what fraction of week 1 and what fraction of week 2 were 10-inch pizzas. Week 1 is very straightforward. We can see that we sold 512 10-inch pizzas in week 1 out of a total of 743 pizzas. So the proportion that were 10-inch in week 1 is simply going to be 512 divided by 743. Okay, so we just tap that into the calculator. 512 divided by 743. I'm going to write that down as a decimal so it's easy to compare with the other one. 0.689. 0.689. So that is the proportion that was 10-inch in week 1. Now in week 2 you can see that this number here is how many pizzas were sold altogether, and this number is how many 10-inch pizzas were sold altogether, and the other branch is how many 12-inch pizzas were sold. So you can see the 758 and the 307 should again add up to the 1065. So then in week 2 the proportion then is 758 out of a total of 1065. And what's that as a proportion then? So again, tapping that into the calculator, 758 divided by 1065 gives me, as a decimal, 0.711. I'm going to round it up to 0.712, I think. 712 to 3 significant figures. So then clearly this one is the bigger number, isn't it? Week 2. Now we've got some space to write our answer here, but we wrote it up here. It doesn't really matter as long as you've got your work somewhere that's convenient for you. And I tend to work near the diagrams rather than all that way down there. It's perfectly fine. So week 2 is the solution, is the answer. 12B. The table shows the profit or loss that a takeaway makes on each pizza. So a 10-inch pizza at normal price makes £3.74 profit, and on offer price it loses 51 pence. And a 12-inch pizza, it normally makes a £5.29 profit, or on the offer price it loses 4 pence. Okay, so when they're selling them on offer, the company is actually making a loss on these pizzas. Right, so then in week 1 the total profit was £1,895.55. At the end of week 1, the takeaway spent £175 on adverts. Was the increase in profit in week 2 more than the cost of the adverts? You must show your working. Okay, so this is actually quite a complex question. We need to go back and look at this frequency tree and use it to work out exactly how many types of pizzas we sold of each type, and then work out all the various profits and loss. Okay, so let's have a look at the 10-inch pizzas first of all. We sold 396 at normal price and 362 on offer price. So for 10-inch, $396 at full price, so that was making us a profit of £3.74. And then we sold, how much was the other one? 362. So 362 on offer price, and the offer price loses us 51 pence. I'm going to make that a negative number then, because it's actually negative profit, isn't it? Okay. I'll get the calculator out and work all those out in a minute. And then 12-inch, They make a profit of £5.29 if they're full price, and 4 pence loss, so that's 0.04 negative if they sell a 12-inch pizza on offer price. And we had 164 and 143 of those. So 164 and 143. Okay, so now we can work out all these and then add them all up and see what we got. Okay, so over to the calculator. 396 times 3.74 means we made £1,481 and 4 pence on normal 10-inch pizzas. Then we sold 362 pizzas where we were making a loss of 51 pence per pizza. So how much is that then? 362 times 0.51. That comes up to £184.62. Remember, this is a negative one, so that's minus 184.62. Okay, now the next one is for 12-inch pizzas. At normal price, we sold 164, and they normally make a profit of £5.29 each. So that is a full profit of £867.56. 867.56. And then finally we sold 143 with each one losing 4 pence. So 143 times 0.04. That gives us a loss of £5.72 on that one, minus £5.72. So our total profit for the week then is going to be those added and subtracted from each other. So the profits, or the positive values, are 1481.04 plus 867.56. So add the positive ones together first, and then I'm going to take away the losses. So 184.62 and £5.72. So I make that a grand total of £2,158.26. Okay, so that was our profit in week 2. So this is week 2. Okay, now in week 1, what did we make in week 1? Okay, now we're told in the question that in week 1 the total profit was £1,895.55, and it says at the end of week 1 the takeaway spent £175 on adverts. Was the increase in profits in week 2 more than the cost of the adverts? Okay, so if we add up the cost in the profits in week 1 plus the adverts, is that more or less than the profits from week 2? So week 1 plus advert equals £1,895.55 plus 175. You should always write down what you're going to type into the calculator. So I'm going to type that into the calculator. 1895.55 plus 175. That comes to a total of £2,070.55. So £2,070.55. And you can see then, so the amount of money that they made in week 2 was a little bit more than that then, wasn't it? So what do we need to find? What was the increase in profits more than the cost of the adverts? So I can just say that yes, profit in week 2 exceeded week 1 plus advert. Okay, So they made more money in week 2 than they did in week 1 plus the cost of the advert. So it was a good offer for them. Question 13. A car travels 3.5 miles in 5 minutes. Work out the average speed in miles per hour. Okay, well, this is a distance, speed, time problem. I don't know if you used the DST triangle to remember which way around it all goes. So distance, speed, time. So what are our 3 values that we've got here? Which one have been given, which one we need to find? So a car travels 3.5 miles, so distance is 3.5 miles. Speed is what we're trying to find, and time is 5 mins. Now 5 minutes in terms of miles per hour, what's that then? So there are 60 minutes in an hour, so that is 5/60ths of an hour, isn't it? 5 minutes, so t is equal to 5 over 60. Right, so we want to find s. What we do is we cover up the thing that we want to find in the DST triangle, and that tells us what to do with the other 2 things. So average speed then is going to be distance traveled divided by time taken. And in this case, we've got a distance of 3.5 miles, and we're dividing that by 5/60ths. Now, you can actually type that straight into your calculator, or you can remember that dividing through by a fraction is the same as flipping the fraction over and multiplying. So another way of looking at that is 3.5 times 60 over 5. Okay, we can type that into the calculator now. 3.5 times 60 over 5 is 42. So that's 42 miles per hour. Question 14. A triangle has base 9 centimeters and perpendicular height of 5.6 centimeters. Work out the area of the triangle. Now, area of a triangle is always half base times height, isn't it? It doesn't matter that this height is kind of extended off the end of the base. We still just use that baseline and that height to work out our area. So it's just going to be a half times our base, which is 9, times our height, which is 5.6. What's that? Reach for the calculator. 0.5 times 9 times 5.6. That comes out to be 25.2. Okay, that's my answer, 25.2. Question 15. 4 positive whole numbers add up to 36. One of the numbers is a multiple of 7. The other 3 numbers are equal. Work out the result when the 4 numbers are multiplied. So, 4 positive whole numbers add up to 36. One of the numbers is a multiple of 7. And the other 3 numbers are equal. So let's call the ones that are equal x. So I've got x plus another x plus a different number. Let's call it y for now, and that adds up to 36. Okay, so I can rewrite that as 3x plus y is equal to 36. Agreed? So they're my 3 equal numbers plus a different number. Now let's have a look at this bit. One of the numbers is a multiple of 7. That's our y one, isn't it? So then y is a multiple of 7. Well, the multiples of 7 less than 36 are 7, 14, 21, 28, and 35. Okay, so let's just try some of these out then and see what we get off, where we get to. So if y is 35, then 3x plus 35 is 36. Now the difference between 35 and 36 is 1, subtracting 35 from both sides. That would leave me with 3x is equal to 1. So x is equal to a third. Now we're told at the top that all the numbers are positive whole numbers. So that is not possible. So that's not a possible solution. So y cannot be 35. Okay, so let's try the next possibility. So it's not 35. What about 28? So if y equals 28, then 3x plus 28 would be equal to 36. Now the difference between 28 and 36 is 8, isn't it? So 3x would be 8. And again, 8 is not divisible by 3, so that is not going to give me a whole number. So that doesn't work, so 28 doesn't work either. Let's try our next option. So 28's out. What about 21? So if y equals 21, then 3x plus 21 would be 36. Difference between 21 and 36 is 15, isn't it? So 3x would be 15, making x equals 5. So that one is that's a possibility. Y is 21, x is 5, 5 and 5. That works. Let's just try the other two options, 14 and 7. So if y was 14, 3x plus 14 would be 36. That would make 3x equal to, difference between 36 and 14 is 22. That doesn't work. 22 is not divisible by 3. And then finally, if y is equal to 7, then 3x plus 7 is 36, making 3x equal to, take 7 away from both sides, 29. Is 29 divisible by 3? No. So it's not 7 either. Okay, so the only possibility then is this one. Y is 21 and x is 5. Okay, so work out the result when the four numbers are multiplied. So now we know what the three numbers are. We need to work out what they are multiplied together. So my numbers are 5, 5 and 5. And 21. And what's 5 times 5 times 5 times 21? 5 times 5 times 5 times 21. That's 2,625. Question 16. A sketch of triangle ABC is shown. And we can see a triangle here. There's an angle marked at A, which is 37. We've got one side AB, which is 11, and another side AC, which is 8. And it says, in the space below, complete an accurate drawing of triangle ABC. Okay, and if we scroll down, we can see that AB has been drawn for us already. And if your school reprographics department has done a good job, that should already be 11 centimeters long. Just be aware that sometimes when these papers are reproduced in schools, they get stretched or squished a bit, so they might not be accurate. Okay, but this one is exactly 11. Right, so the first thing we need to do is to construct a 37-degree angle at A. So it's time to get the protractor out, lay it along the line AB with the center of the protractor at A. And then a protractor always has two scales. You want to pick the scale that starts from 0. In this case, that's the inner scale. So counting around from 0 up to 37. I'm going to put a little mark at 37 degrees. And once I've done that, I'm going to remove the protractor and get out our ruler instead. I'm going to line up the ruler. So the 0 on the ruler is at A, and the ruler passes through the mark that I've made. And then I'm going to carefully measure along it to 8 centimeters and draw the line. Okay. Now once that line's been drawn, then the end of that line is going to be the point C. And then I can join C down to B with another straight line. Okay. Job done. Question 17. Simplify 7x minus 3x minus 2x. Okay. Now, remembering BIDMAS, B-I-D-M-A-S, brackets come first, don't they? So got to do this bit in the brackets first. So what is 3x take away 2x? Well, 3x take away 2x is x, isn't it? So that becomes 7x take away x. And 7x take away x is 6x. So it's that one there. Okay. Another way of doing it is you could just remove the brackets and say that's the same thing as 7x take away 3x plus 2x. But anyway, I think what we did was probably the easiest thing. Question 18. A competition took place in 1983 and it takes place every 6 years. Circle the year in which it was also taking place. Okay, so it took place in 1983. So, and it's going on every 6 years. So, aren't we just adding on 6 to 1983 until we get to the right one? Well, let's do that then. So 1983, I think what I'd like to do is get past 2000 and then look at it again. So if I add 6 on, that takes me to 1989, and another 6 takes me to 1995, and 6 after that takes me to 2001. Okay, right, so then let's just think about this. Then if I take 2001 away from these numbers, that's going to leave me with 82, 35, 48, and 22 then, isn't it? Then I really just need to work out which one of these is a multiple of 6, because if it's a multiple of 6, then it will be 6 years, a multiple of 6 years after 2001. So is 82 a multiple of 6? No. It's not in the 6 times table. Is 35 in the 6 times table? Nope. 36 is, but not 35. 48. Is 48 a multiple of 6? Yes, it is. It's 8 6s are 48, isn't it? Is 22 a multiple of 6? No, it isn't. So it must have been that one there. It must have been 2049. Question 19. In an election, there were 4 candidates, J, K, L, and M. Names obviously changed there to protect the innocent. Fran is drawing a pie chart to show the results. The sectors for J and K have been drawn. Okay, so we've got J and K there. So we know that J was 72 degrees and K was 90 degrees. And we're told that twice as many people voted for L as for M. We need to complete the pie chart. Okay, so we don't know how many people voted for L and M, but we know that twice as many voted for L as for M. So let's say that the number of people who voted for M is X. Then the number of people who voted for L then is going to be 2X, and between them they got 3X votes. Okay. Now, what else do we know? Do we know anything else? No. So anyway, that's 90 degrees, isn't it? So between them, J and K got 90, 100, and 90 plus 72. That's 162 degrees. So that means L and M between them must be the remainder of the pie chart. So we've got 360 degrees altogether, less the 162 that the other two got. So what does that leave us? 360 minus 162, that's 198. Okay, and so we've got 198 degrees to share out then in between M and L. Okay, now remember L got twice as many as M. I think I'm going to change my mind. I'm not going to do this as X and 2X. I'm going to use a ratio. So the ratio of L to M, twice as many people voted for L as for M. So that's in the ratio of 2 to 1. So 2 plus 1 gives me 3. So there are 3 shares. So dividing 198 by 3 tells me the value of each share. So 198 divided by 3, that gives me 66. So then taking my ratio of 2 to 1 and scaling it up by a factor of 66. So 2 times 66 is 132. 2, and 1 times 6 is 66. And you can see that 132 and the 66 together give me 198. So now I just need to complete the pie chart. So then what you're going to need to do is lay your protractor out on this shape. Your protractor is going to end up on here, oops, something like that, and you're going to measure around to 66 and mark it and draw your angle on. So for my diagram, it's going to end up looking something like this. So that's going to be my 66-degree angle in there, representing M, and L is going to be this bigger part here, which should be, and you probably want to check that that's also the case, that is 132 degrees in there. Okay, and that completes your pie chart. 19b says, altogether 16,200 people voted. How many voted for J? Now, if you remember from the diagram, J had an angle of 72 degrees at the center. So the fraction that voted for J is going to be 72 over 360, because there are 360 degrees in the circle, and 72 of them were for J. Okay, so it's 72 360ths. So we're going to use 72 over 360 as a fraction and multiply that by the total number of people who voted, which is 16,200. So then tapping that into our calculator, 72 over 360 times by 16,200. And that comes to 3,240. 3,240. That's my final answer. Question 20. The probability that A is the outcome of an experiment is 0.2. Circle the probability that A is not the outcome. Okay, now the probability of an event not happening is 1 minus the probability of the event happening. So in this case, it's going to be 1 minus 0.2, and 1 minus 0.2 is 0.8. Question 21. Rearrange E equals 2F to make F the subject. Okay, so if E is equal to 2F, if I divide both sides by 2, this is very similar to the first question. I'm going to cancel those out and leave me with F equals E over 2. F equals E over 2. Question 22. Here is a rule for a sequence. After the first two terms, each term is half of the sum of the previous two terms. Okay, so what you need to do then is you need to take these two terms, add them together, divide by 2, and you get the next one. So 2 plus 10 is 12, and 12 divided by 2 is 6. Right, so show that the sixth term is the first one that is not a whole number. Okay, so basically we've been given the first three terms, and we need to find the rest up to number 6, and hopefully that will be the first one we encounter that is not a whole number. Okay, so we can see that when we add 2 plus 10, we get 12 divided by 2 is 6. So then our third number is going to be my 10 plus 6, which is 16 divided by 2, and 16 divided by 2 is 8. So that one there is 8. Okay, so our that's our fourth number, isn't it? Not our third. That's our fourth number. So our fifth number then is going to be our 6 plus our 8 divided by 2. 6 plus 8 is 14, and 14 divided by 2 is 7. So again, that is a whole number. Okay, then our sixth term, so that's 8, that's a 7. So our sixth term is we're going to get by taking 8 plus 7 divided by 2. 8 plus 7 is 15. 15 divided by 2 is 7.5. So there we go. Our sixth number is the first one. That is not a whole number. So let's just draw attention to that. Not a whole number. Okay. Question 22b says a different sequence follows the same rule. So the first term is 4 and the third term is 9.5. Can we work out the second term? Okay, so we've got a term missing in this sequence. I'm going to call that term x because it's algebra. Right, so then our third term is going to be our first two terms added together divided by 2. And that is equal to 9.5 because we were given it. So basically what we've done here is we've formed an equation in x that we can then go on to solve. Right, now first off I'm going to get rid of this divide by 2 by times in both sides by 2. And then that will cancel with that, leaving me with just 4 plus x on the left. 9.5 times 2, 2 9s are 18, 2 halves are 1, so that's 19 altogether. So that's given me 4 plus x equals 19. Then subtracting 4 from both sides, that's going to cancel with that, leaving me with just x on the left, and 19 take away 4 is 15. So my middle term must have been 15, so that when I added it with the 4 plus 15 is 19, divided by 2, I got 9.5. So that seems to work. X is 15. Question 23. In a group of 20 people, 7 own a dog, 3 own a cat, and 12 do not own a dog or a cat. Aidan shows this information on a Venn diagram. Okay, so make 2 criticisms of his Venn diagram. Firstly, this and this are in the wrong place, aren't they? Okay, the universal, that little squiggly E is the universal set, and really that should be written in the top corner here, not outside the box. The box represents everything, so everything should be inside the box. So similarly, this 12 sitting on the outside here, that should also be on the inside. So that's another criticism. 7 own a dog, 3 own a cat, 12 do not own a dog or a cat. Okay. Well, another criticism is we don't know who owns a dog and a cat. That's a possibility as well. In fact, it has to be, because 12, 7 and 3 adds up to more than 20. So some of these are actually going to be in here as well. So there's lots of things wrong with this Venn diagram actually. So I'm going to say firstly, the universal set, which is the squiggly E, and the 12 should be inside the rectangle, not outside. That's my first criticism. And my second criticism then is that 12 plus 7 plus 3 adds up to more than 20. 12 plus 7 plus 3 is greater than 20, which basically means that some people owned a dog and a cat. Okay, advertisement break. Hopefully you are able to use this past paper to identify any topics that you still need to focus on for your exams. It's best if you do some focused revision around these topics between past papers, and this series of videos will help you do just that. They are based on the AQA topic tests, including key topics like trigonometry, surds, indices, and a whole lot more. Click on the card above to go to the playlist. I'm adding to this collection all of the time, so if the topic is you're looking for is not yet covered, it soon will be. So subscribe below to make sure you don't miss out on any of these uploads. Right, back to the maths. A is a common factor of 72 and 120, and B is a common factor of 6 and 9. Work out the highest possible value of A over B. Okay, so this fraction is going to be its biggest when A is at its maximum value and B is at its minimum value, isn't it? Okay, you'll get a bigger number if you divide a fraction by a smaller denominator. So let's take B to start with then. I think that one's going to be easier. A common multiple of 6 and 9. If we want B to be minimum, we're actually asking for the lowest common multiple of 6 and 9. Okay, so let's think about the multiples of 6 and 9. The multiples of 6 are 6, 12, 18, and so on. And 9 is 9, 18, 27, and so on. So you can see we found our lowest common multiple already. 18 is there, 18 is there. So our LCM then of those two numbers is 18. So that's going to be my value of B. What about A then? We've got A is a common factor of 72 and 120. So let's list out the factors of 72 and 120. I tend to write them down in factor pairs. So 1 goes with 72. 2 goes with, well, half of 72 is 36. I think 3 must go into it then as well. So 3 and 24, is that? 3 and 24. 4 and what? 4 and, that's got to be 18, isn't it? 5, no, 6. Yeah, 6 goes into it. 6 and 12. 7, no, 8, yes. 8 goes with 9. And look, I've met myself coming down the other way, so that's as far as I'm going to get. So quite a lot of factor pairs of 72. What about 120? We're going to have so many. So I've got 1 and 120. 2 and 60. 3 goes with 40. 4, yes, goes with 30. 5 goes with 24. 6 goes with 20. Also got a lot of factors. 7, no. 8, yes. 8 goes with 15. 9, nope. 10, yes. 10 goes with 12. And then I've got 11 in between. That's not going to be a factor. So that's all of them. Gosh, lots of factors for both of those numbers. So we want the HCF then of those two numbers. So we want A to be as big as it can be. So it's going to be the highest common factor of those two. So looking through my list, 72, no, 36 is my next biggest. That isn't on my list. 24, yeah, that's on my list. So look, 24 there, 24 there. So the HCF of these two numbers is 24. Okay, so what's the highest possible value of A over B then? Is going to be, so that was my A value, wasn't it? 24, and B is 18. So my highest value is going to be 24 over 18. Okay. Which I could cancel down, but I'm not sure I need to. So it could simplify to 4/3. Also an acceptable answer. A and B are similar shapes. B is an enlargement of A with a scale factor of 1.5. Work out the values of X, H, and W. Okay, so first off, I've got X. Now that is the angle at the tip of my chevron. If two shapes are similar, then all the angles are going to be the same. So that's going to be just the same as 54, isn't it? So I'm going to say that X is equal to 54 degrees. Okay, now my 5 centimeter one matches up with my H, and our scale factor we're told is 1.5. So then H is going to be 5 times 1.5, which is 7.5 centimeters. Okay, and then finally, what have I got? I've got W here and 9 here. So if I timesed W by 1.5, I'd get 9. So then W is going to be 9 divided by 1.5, isn't it? So W equals 9 divided by 1.5. Okay, can you do that in your head? I can, but just in case you can't, let's just tap it into the calculator. 9 divided by 1.5 is 6. Okay, so I've got X is 54 degrees, H is 7.5 centimeters, and W is 6 centimeters. Investment A, save £150 per month for 2 years. 2.5% interest is added to the total amount saved. Or we've got investment B, invest £3,500. Compound interest is added at 3% per year. After 2 years, how much more is investment B worth than investment A? Okay, let's start with investment B then. Save £150 per month for 2 years, and 2.5% interest is added to the total amount saved. So if we're saving £150 per month for 2 years, then we've got 150 times 2 lots of 12 months, which is 24 months. What's that then? So 150 times 24, that comes out to be £3,600. Okay, slightly more than the investment B. And then 2.5% interest is added to the total amount saved. So using our final original multiplier triangle, we want to know our final amount, and that is going to be, well, if I put my thumb on F, then I can see it's original times multiplier. Okay, so F here is what we're trying to find. O is the original amount, which is 3,600. And the M, the multiplier, is a 2.5% increase, isn't it? So it's 102.5%, which as a multiplier is 1.025. So my amount then is going to be 3,600, my original, times my 1.025. And that is equal to times 1.025, that's 3,690. Sorry, that was investment A up there, wasn't it? I'm doing investment B now. I'll get it the right way around. So that was investment A, and now I'm doing investment B. So investment B is invest £3,500 compound interest at 3% per year. So again, using my triangle, F is equal to the amount I'm trying to find. The original this time is 3,500, and the multiplier is an increase of 3%, so that's 103% as a percentage increase, which is 1.03 as a multiplier. So then my final, again, is going to be my original times my multiplier. But because it is compound interest, I'm going to raise that to the power of the number of years that we're going to do it for. So that's going to be 3,500 times my 1.03 raised to the power of 2. Okay, tapping that into the calculator. 3,500 times 1.03 squared, which comes out to 3,713.15. 3713.15. Okay, so the question asked, how much more is investment B worth than investment A? So I need to subtract 1 from the other now, don't I? So 3713.15 subtract 3690. So that's £23.15 more, isn't it? £23.15. Now you notice I'm using a new emulator or a new calculator this time. I've switched over to the Casio FX83 GTX, which is the new Casio model. Very nice piece of kit, and if you haven't got a calculator yet already for your exams, then this would be the one to go for, I think. I'll put a link to my shop in the description below, so you can click on that to find all my recommendations for calculators and revision guides and things for your GCSEs. Okay, let's move on. Show that the lines y equals 3x plus 7 and 2y minus 6x equals 8 are parallel. Do not use a graphical method. Okay. So 2 lines are parallel means that they are sharing the same gradient, isn't it? Their gradient is going to be the same. So the gradient of one is going to be the gradient of the other, and if you can show that is true, then they must be parallel. Now the first equation, y equals 3x plus 7, that's very easy to see the gradient because it's in the form y equals mx plus c. So if it's in the form y equals mx plus c, then you just really need to read out that number in front of the x, and that is going to be the gradient. So for equation for y equals 3x plus 7, so for y is equal to 3x plus 7, then our m, m1 I'm going to call it, is equal to 3. So the gradient of that equation is 3. Like I say, it's just this number here in front of x, the coefficient of x. Now the second equation I've been given is not in the form of y equals mx plus c. So we're going to have to rearrange it first. So starting with 2y minus 6x is equal to 8. Can I get it into the form y equals mx plus c? Yeah, I can. What I can do is just move that one over the equal sign, or add 6x to both sides. So that's going to give me 2y is equal to 6x plus 8. Still not quite in the right form. I'm going to have to divide both sides by 2 so I can get y is equal to something. So that's going to give me y is equal to, now 6x plus 8 over 2. I can divide the 2 into the 6x and into the 8, and that's going to give me 3x plus 4, like that. So now it is in the form y equals mx plus c, and you can see the gradient there is also 2. So I can say that m2 is also equal to 3, and therefore m1 equals m2. So they are parallel. Okay, done. Now part B says, is the point minus 5 minus 6 above or below the line y is equal to 3x plus 7? Tick one box, above, below, or on the line. You must show your working. Again, not using a graphical method. Okay, so if I've got a line and I want to know whether my point is up here, on here, or below here, I think what I'm going to do is I'm going to take the x value from that coordinate and I'm going to substitute it into my equation and then see what I get. Okay, and then I can work out then, and then I can have a look at this value here, the minus 6, and see whether or not it's bigger or smaller than the value I get when I sub minus 5 into the equation. Okay, so let's do that then. So if y is equal to 3x plus 7, so when x equals minus 5, then that gives me y, which is equal to 3 lots of minus 5 plus 7. So 3 lots of minus 5 is minus 15. So that's minus 15 plus 7. And minus 15 plus 7 is going to be negative 8. Okay. So this then has a coordinate of minus 5, minus 8. That's the point that lies on the line. Lies on the line. Okay. So then imagine we've got our line that we now know that this point here, when x is minus 5, is minus 8. Now where is the point minus 5 minus 6. That's got to be more above it, isn't it, on the great scheme of things. Minus 5 minus 6. Negative 6 is more positive than negative 8. So it's going to lie above the line. The cost of a ticket increases by 10% to £19.25. Work out the original cost. Okay. Now I always do my percentage questions using this triangle, final, original, multiplier. You just cover up the one that you want to find, and then that will give you the equation that you need. So here, final, well, I'm working backwards, aren't I? So I've been given the cost after the increase. So the final is 19.25. The original is what I'm trying to find. And the multiplier, it's a increase of 10%. So if I start with 100 and I add on 10, I've now got 110%, which as a multiplier is 1.1, isn't it? Okay, so I want the original. So let's cover that up. And that means my original is equal to final divided by multiplier. Original equals final divided by multiplier, which in this case is £19.25 divided by 1.1. This is a reverse percentage question, isn't it? If you do it a different way, 19.25 divided by 1.1 on my calculator comes out to be 17.5. This is in pounds and pence though, isn't it? So that is £17.50. I have to put that extra 0 on if it's money, otherwise you lose an accuracy mark. So the answer is £17.50. The nth term of a sequence is 12n minus 2. Work out the numbers in the sequence that have 2 digits and are not prime. Okay, the nth term of a sequence is 12n minus 5. Work out the numbers in the sequence that have 2 digits and are not prime. Okay, so why don't we just try listing some of these numbers out. When n is 1, I'm going to have 12 lots of 1 minus 5. So 12, so n is 1. What we're going to get 12 lots of 1 is 12. Take away 5 is 7 then, isn't it? And then when n is 2, so that's not got 2 digits, but when it's 2, it's 24 minus 5, which is 19. N is 3. 12 times 3 is 36, minus 5 is 31. 4 is 4 12s are 48, subtract 5 is 43. 5 12s are 60, subtract 5 is 55. 6 12s are 60, 72, take away 5 is 67. 7 12s are 60, 72, 84, take away 5 is 79. 8 12s are, well, so I suppose what we're doing, we're going up in 12s here. I'm getting a bit bored of doing it this way. Let's just go up in 12s. It probably works just as well. 79, 89, 91, and then 9 is going to be over 103. Okay, so that one's bust. So obviously 7 isn't one of them because it hasn't got 2 digits, and nor is 103. So what we've got left have 2 digits and are not prime. Okay, so let's cross out the prime numbers. 19 is prime. 31 is prime. 43 is 43 a prime number? I'm not sure. Let's have a think. Yeah, I think it is 40. I can't think of any factors of 43. I think that's prime. 55 isn't prime. That's the 5 11s, isn't it? And 67 is 67 prime? Yep, it is prime, and 79 I think is prime as well. So the only ones that are not prime are these two then, 55 and 91. So they're going to be my answer, 55 and 91. I've been given A, B and C as column vectors, and I need to work out what A plus B plus C is. Okay, so if I want to add these three vectors together, I'm going to be adding 6 minus 10. I'm going to be adding on negative 1, 2, and C, which is minus 4 over 7. So when I add column vectors like this, I'm going to be adding like the x components together. Those three are going to get added together, and I'm going to add the y components together, the minus 10, the 2, and the 7. Okay, so what does that give me then? 6 plus negative 1 is 5, plus negative 4 is 1. And negative 10 plus 2 is negative 8, plus 7 is negative 1. So that's going to give me 1, negative 1, 1, negative 1. 30b says, show that vector A plus 2 lots of vector C is k lots of vector B, where k is an integer. Now this k here is another scalar, and this is a scalar. So vector A plus 2C, let's start with the left hand side. That is our vector 6 minus 10 plus 2 lots of our vector C, which was minus 4, 7. So when I've got a scalar outside of a vector like that, I need to multiply both numbers inside my vector by that 2. So that is going to be the same thing as 6 minus 10 plus 2 lots of negative 4, which is negative 8, and 2 lots of 7, which is 14. Okay, so that becomes 6 minus 10 plus negative 8, 14. So now we can do the vector addition. So this one plus this one, and this one plus this one. That gives me 6 plus negative 8 is negative 2. Negative 10 plus 14 is 4. So that gives me negative 2, 4. Now if you remember, B was the vector minus 1, 2, which is half really, half the numbers, isn't it? So minus, if I take minus 2 and divide it by 2, I get minus 1. If I take 4 and divide it by 2, I get 2. So another way of thinking about this is I've got 2 multiples of 2 here, and I can factorize out that 2 and write it as a scalar at the front. So 2 times minus 1 is minus 2, and 2 times 2 is 4. So I've rewritten minus 2, 4 as 2 lots of minus 1, 2. And minus 1, 2, if you remember, is the vector B. So I have shown that A plus 2 lots of C is the same thing as 2 lots of B. So that's all. We've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.